Hello and welcome to the Ethereum blockchain structure lecture. So today we're going to discuss the Ethereum blockchain structure, and we're going to look into which elements are different from the Bitcoin block header. So can you already think of which ones are probably the same or not? Think for yourself for a second, and then we're going to discuss. So the same fields exist in Bitcoin. It's notably the previous height, it's the block timestamp, it's the nonce, which is used by the miners to change the block header for the mining purposes. The proof of work difficulty is the same here, and I think there's some kind of an extra field in the block header that exists. And these are basically all the parts that exist in the Bitcoin header as well as in the Ethereum header. However, what's new is the block height. This is something you can compute in Bitcoin. You don't really need it in the header. It might help some clients. I am not sure. I don't think there's a minor field there. And what's certainly new is the state root, transaction root, and the receipt root. So now the state root is stored here within a Merkle tree. Now, to be precise, it's a Patricia Merkle tree, and you can see it maps the address to a particular set of data that is stored within this particular leaf. The transaction root is something that has at its leaves the transactions that we will look into in more details later. The receipt root has the results of the smart contract or the state transition, smart contract execution or state transition, which gives us the final state, how much gas was used, some output as well. So a Patricia Merkle tree is basically a tree that allows you to search here, for example, the word T along this path. And then you arrive at this leaf here. Right? So this is a tree for the following keys here that you can look at. And there might be different trees. For example, this tree here allows you to search for toasting. Right? You go here to T, toast, and then ing. How does this work now in the actual Ethereum blockchain? So we start at the block header. So this is the block header that we've seen at the beginning of this lecture, and then there's a catchuck 256 hash that is taken from the root of the Merkle tree, right? So here you have a root, and now we have here a list of keys that we want to look up. So let's, for example, look at the first one. So it starts with A7. So here there's A7, and then it tells us to go to the next node, which goes here. There's number 1, right? And from there we're getting to a key end, which is 1355, and this corresponds to here 1355. So we do find that the value here is 45 ether of this particular key, and that's basically how this data storage function is being used to store data in the Ethereum blockchain.